Hello and welcome to my chemical practice teaching extra assignment video. In this video I will be discussing this learning objective, which is how to calculate the relative atomic mass of elements with more than one isotope, and evaluating two exam questions to do with this topic. So, as I said, the learning objective is as shown. But before we get into the process of this learning objective, I want to cover two key definitions and to do with this. The first one is relative atomic mass and the second is isotope. So the relative atomic mass is the average mass of its atoms compared to 1/12 of the mass of a carbon-12 atom. An isotope is a variant of an element with the same number of protons but a different number of neutrons. Now I've put in bold two of the key parts of those definitions, as the average mass of its atoms is very important, and the fact that in an isotope is a different number of neutrons is very important, as that will affect the mass of each isotope. So how to calculate it? To find the relative atomic mass is essentially the average mass, and the average mass depends on two things: the mass number of its isotopes and the abundance of each isotope. So, using an example of copper, copper has two isotopes, which copper-63 and copper-65. Each of the according abundance is shown. So, in your exam, you will get an equation for the relative atomic mass. However, it's good to understand where it comes from. So, the top half of the equation is the total mass of atoms, and the bottom number is the total number of atoms. So to work out the total mass of atoms, you use the mass of one isotope, multiply it by its according abundance, and you add to that the mass of the other isotope times by its abundance, and the total number of atoms is the total abundance. So you add the two abundances together. Note that the abundance on the bottom will always be 100. It could be easy, rather than having to add them together, and it's just quickly to know that it's always going to be 100. So the total mass of atoms is 6,362, and you divide that by 100, which equals 63.62. It is a very simple calculation. However, you can slip up with the working out the total mass and stuff. So it is very important you follow this process. So applying this to exam questions, this is the exam question that I've chosen. It is: the sample of lithium is found to contain two isotopes, lithium-6, lithium-7, with the abundance is as shown. And so here is the equation that you're given, and it is the same format as the one that I used. Obviously, it just applies it differently. So to do this, you do the isotope 1 mass, which is 6, times its abundance, which is 7.59. And then you add that to the isotope of the second isotope mass, which is 7, times the abundance, which is 92.41, over 100, because it's total abundance. And this is 692.41 over 100, which is 6.9241. However, looking at the question, it tells you to do it to three significant figures. Therefore, you would put your answer as 6.92. Very simple. Another example is this question: use the information to calculate the relative atomic mass of potassium. And so this one actually has three isotopes. So potassium 39 with the abundance of 39, potassium 40 with the abundance, that's the mass of 39 and the abundance of 93, 40 with the abundance of 0.0122, and potassium 41 with the abundance of 6.88. So again, putting it into the equation, you times the mass of isotope 1, which is 39, times its abundance, which is 93.1. The mass of isotope 2, which is 40, times the abundance, which is 0.0122. And then the mass of isotope 3, which is 41, times its abundance, which is 6.88, over total abundance, which is 100, which equals 3,913.468 over 100. And this comes out to be, put it in calculator, this comes out to be 39.12468. Again, looking at the question, really important that you go back to look at the question, because it might not always be three significant figures. Obviously, in this case it is. So it will be 39.1. So that is the end of my slideshow on working out the relative atomic mass of an element with different isotopes. I hope you understand and have learned something from this and will hopefully succeed in your exam. Thank you very much.